The compiler has a trick that helps us not walk off the end of arrays and strings. This type of table is called a truth table, and they can be used to show how Boolean operations work. In this one, it is showing how our AND and OR operations get computed. Each of them have two operands, A and B. Each row in the table shows one possible pairing of values for those two operands, and then gives the value of A ampersand ampersand B and A vertical bar B.
You can see that A ampersand ampersand B is true only if both operands are true. Only if A and B are true. A vertical bar B is true if either operand is true. If A is true or B is true.
There is an important thing to notice from this table. For each of these operations, there is a chance that we know the result by only looking at the first operand. For AND, if the first operand is false, there is no way that the ampersand ampersand operation can evaluate to true. And for OR, if the first operand is true, we know that the vertical bar operation must evaluate to true. The machine always evaluates the left-hand operand before it evaluates the right-hand operand.
You really love to overwhelm us with teeny tiny details.
You're right, but only when those details matter. To show why that matters, let's study this loop.
Be the machine.
Okay, I gets the value 0. Then the loop checks to see if the thing in the 0th position of the array is greater than 0. For this array, 42 is greater than or equal to 0, so we do what's in the loop and increment I. Back to the top of the loop, is my array sub I greater than or equal to 0? Nope, negative 14 is less than 0, so the loop stops. Zumi, can you generalize what this loop is doing?
It's searching for the first negative number in the array.
That's right. When the loop finishes, I will be the index of the first negative number in my array. That makes me a little worried about what happens if there aren't any negative numbers in the array. So let's play with this example. I will start at 0 and walk through the array. Since there are no negative numbers in the array, I will increment all the way to 3. And then we'll try to index my array by 3. What will that do?
Array out of bounds exception because we walked off the end of the array.
Oh no, we better do something about that. In our usual walking through the array loops, the condition that stops us from walking off the end of the array is checking to see if our loop variable is less than our array's length. That's essentially checking if I is safe for indexing our array. We can combine that with our check for whether the thing in the ith position of the array is positive. This loop will stop if we've walked off the end of the array, or if we find a negative number. This is where those original details about the AND operator matter. Think about what is happening when we're walking off the end of the array. At that point, I equals myArray.length. That will make the first condition false. Since the compiler knows that false for the first operator of AND means that AND has to be false, it won't bother to evaluate this other operand. That means we'll never index myArray by I, and that's critical because since we're off the end of the array, doing that indexing would cause an exception.
Excuse me, I think we need an example. The variable I starts at 0. If this is the data in our array, I is less than 3, and 42 is greater than or equal to 0, so I will get incremented to 1. I is still less than 3, and 14 is greater than or equal to 0, so I will be incremented to 2. I is still less than 3, and 19 is greater than or equal to 0, so I will be incremented to 3. Now, I is not less than myArray.length. They are now equal. Since the first part of the AND is false, the compiler knows there's no way that AND is ever going to be true, so it won't execute the second part of the AND. And that's good, because if we did, we would index my array with a 3 and get an array out of bounds exception.
Very nice. When we do this, that first condition is often called a guard condition because it is guarding the second comparison. It is essentially checking to see if it is safe to execute that second comparison. Just to be sure that we see why those details matter, let's think about what would happen if we reversed the order of the operands of the AND. Let's see what that does to Zumi's example.
In this case, when I becomes 3, since the machine evaluates the left-hand operator of the AND first, it will try to index the array by 3, and will still get that array index out of bounds exception.
You're very good at this. The bottom line is that the order of the operands of AND and OR matter because the value of the first can decide what the result is, and when that happens, the machine won't bother to evaluate the other operand. We can use this to build guard conditions to prevent exceptions. Hey, Jejun, see why those details mattered?
Yeah, this time I do.